Alright guys, we're doing a little video on how to use Cypcut for nesting. A lot of people don't know how to do this, and I really haven't found any good videos demonstrating it. I use nesting all the time. It saves a lot of material and only creates a few headaches, which I'll explain later. So the first thing, to nest a component, we are going to go up to File, go to Nest, Import Parts. I always do everything in DXF. I don't save it as laser documents because I'm always changing how I do things. So now we're going to select this part here. These names should all be blurred. It's, you know, for a reason. So we have this part over here. That's the one we want. We hit open. Now, I've already done this a bunch of times. This whole sidebar is full of components. So now we're going to right-click on our part and click Edit Parts. Now here's where we're going to start setting up the component. So the first thing we're going to do is select whatever we want to edit. These top icons up here are only going to have effect on whatever's selected. So if you only want to do, say, certain geometry, like holes inside, you want compensated or different leads, then say outside geometry, just select what you want and then select the outside to edit that part. So, first thing we're going to go ahead and do is hit compensate. Now, I'm going to show you how to calculate this in another video. Basically, you just cut a square of a known size, measure it, and then add on half the amount that it is different. I'm going to check all expand. You can do inner mold, shrink, outer mold, expand, but for certain configurations of the way I do things, that doesn't work. So I select either expand or shrink depending on what I'm doing. So outer geometry, we expand. Hit OK, and as you can see, it has now drawn a second line at a offset distance that I determined, and that white line is where the center of the laser beam is going to travel, and this is going to be the edge of what gets cut. So the next thing we're going to do, we're going to set up our leads. Now I got kind of this funny recipe I like. I use lead in line, 45 degree, 0.5 millimeter length, and lead out. We hit OK, and we're going to change the lead position. So that's this button here, and we're going to select right here. Now if you look, I've got these 45 lines going out. What we're going to do is select inner. That's going to flip it. Now, if you had set your compensation up to automatically find inner and outer, it would flip your compensation, which is why I tell it specifically to expand the compensation instead of letting it figure it out on its own. Then finally, we click micro joint, and for some reason it doesn't select on the white line. You got to go to the line that's your actual part. Select in between these two, and I like 1.4 millimeter. Now what this is going to give you is about a 0.6 millimeter gap in between here, and it's going to start the laser inside of the part, and then it's going to end inside of the part. So it breaks off clean. Well, it's not perfect, but at least the spur isn't sticking out, which will throw off dies and tooling. Your choice on how you want to do that. But now this part is set up, so we're going to come over. We're going to select how many we want, and I want 500 of each of these parts. Check the little boxes that we want them. Alright, so after you have all of your parts, your part numbers figured out and dialed in, you can go ahead and click this button over here that looks kind of like a puzzle piece. And you're going to go, in this case, selected parts. And I use standard plates. In my case, they're 1215 millimeter by 1215 millimeter, which works out to about 4x4. Plate thickness, plate material, really doesn't matter. So now we're going to look at part gap. That's the space in between the components. 3 millimeter works for me and my thin material. Plate margins, 4 millimeter. That works because that's about the width of the laser dot for setting up. So it's good to have a decent margin on there. I'm letting my rotation angle be 90. You could do 45, 180, and then this is do not rotate in Chinese apparently. 90 works. 45 starts adding more potential options for how it can rotate a component, so I just like to leave it at 90. Auto optimize, I'm not actually sure what that is exactly. Remnant will cut the sheet off. Be careful with that. If you set your sheet sizes wrong, it will cut off the sheet, so be careful with that. I've used it a few times. I don't use it too much though. Usually I'll just cut it off with a pair of shears. Max co-edge number. But I don't have co-edge on because my parts are fairly, they require a high level of accuracy. If you have co-edge, it really doesn't use your compensations. So I don't like using it. You can if your parts don't need much accuracy, but then why are you running a laser? Okay, so we're gonna hit OK, and it's gonna start arranging the components onto sheets. And so a few little notes while we're waiting. The limit on how many components you can nest is 999 per component. So if you're doing more than that, you might look into either doing batches of components or using an array copy if the part is, well, so small that you're making that many. The other limit is you are limited to 20 sheets. That is regardless of the size of your machine. So on a little 4x4 like this one, it does start to become a little bit of a problem. Okay, 2100 pieces, 2144. That does not seem like the full number of the components I requested. So I think I hit the limit of how many parts I can do. Oh, another thing to note, that 45-degree internal cut that I did, where I told it to cut inward, if you touch the sort button, that's this button up here, if you touch that, it's going to flip it back the other way. It tries to save you from yourself, but that is an important thing to note because it will put all the bumps outside. Alright, hey, look at this. Okay, so nest plates. So hey, 19 sheets, that's perfect. So yeah, hey, there we go. That is about almost 90% utilization of the material, and as you can see, it only took a minute. So the other little warning I have for you guys, and we keep making this mistake, is you have to manually switch to the next sheet each time, and I have been forgetting to do that, so I end up with you know, like 30 extra components. So let's go ahead and load up the first sheet, and we'll start cutting. Just a little mention, you guys, if you guys do really small parts, geometry like this square is only about just over 1 millimeter wide, or about 50 thousandths of an inch. When it cuts around, it's going to blow out, and sometimes it hits the edge of the nozzle, which causes a capacitance error. Just something to be aware of. Your machine's not broken. It's just parts like this really mess it up bad. Another little thing I wanted to just real quick mention. So, like, here's a great example of owning your own laser is a big advantage. So this component right here, this kind of rectangle, it actually goes through another shearing operation. Now, if I was job shopping this thing out, the job shop's not going to know that. So I know that I can leave a gouge in the side of the component, and it doesn't cause any problems because this all gets trimmed anyway at a later process. So you can do that with a lot of things. This section of this component will be buried underneath another part, so you won't ever see that notch. And that's just one of the many advantages of owning your own laser. So we're going to go ahead. I've already set the sheet. I'm just going to hit start here instead of using the remote. And Mike is going to turn the fan on. Thank you. And we're off. And you can see live speed of the machine cutting right here. That red X is where the position of the center is. In that corner. Yeah, there usually is.
You do have a certain throwaway rate on components. It's just you don't get 100%. You end up throwing away not a ton of parts, but a fair number of them. What, about 2% or so?
But I'd say between 2 and 5% if it's running decently.
Depending on the complexity
and your level, yeah, your level of requirement.
Capacitance error out.
Yep. All right. So what we do then is we don't do anything. We just hit resume, and boom, we're back to cutting again. It does this a lot on this component. I don't think there's really a good way to fix it, so that's just what it is.
Primarily what it is because it's such a large square chunk that's coming out of it. It somehow, it always bumps up and hits the nozzle. There's just no way around that. So, all right, we're going to turn the video off at this point. So these are the components after they came out of the laser cutter. and you can see they're hanging on. We're able to handle them and move them out of the machine. Takes a couple wiggles and the part comes out. And the edges, that little gap is more or less smooth. This one's a little bit of a bump, but this one it's flat with a little nick in it.
Yeah, it's
Alright.
almost minimal. It's very minimal.
Alright, and the same thing with this. There's a little nick in it, but otherwise the parts come out, and we can, at this point, what we do is we take them out onto a flat table with heavy cardboard on it. That's basically other sheets of, this is 16 gauge underneath it, a stack of it, so that you can get the sheet nice and flat and wipe it down to get the cutter dust off of it. Flip it over, repeat wiping, getting the cutter dust off, and then break all the components out and stack them.
And as you can see with the nesting software, it generally goes from largest part to smallest. So this is the biggest component that we have. So it fills the sheet as much as it can, and then it fills in the edges with the next size down that it can. And as you can see, right, where was it? Look through the camera. Right here, it couldn't get one of those other parts on, so it put one of these smaller pieces in. And here's another little note. Even if you got your stuff dialed in really well, you should still expect occasional bad parts. This one's going to get put in the reject bin, and then we'll add it in at the end on the final sheet. Anything else?
I'll just show the problem there.
Yeah.
You can see that's not ideal. But what it is, the sheet vibrated.
Yeah,
nothing to do about that.
It's not the laser's fault. The edge of the sheet was floating a little bit, and when you blow air on it, it starts flapping, and the machine just simply can't keep up with that. But the vast majority of the components are perfect, so that's all we really care about. Alright, we've just finished cutting our first sheet. We've reloaded the machine with a new sheet and set its location using the remote control. Now this is very important to remember to do every time, is to click to the next sheet. Now if you're not sure if you've already done this or not, go ahead and click to the next one. If this stays white, it hasn't been done yet. So just keep that in mind. As a note that I should have mentioned earlier, when you're setting up your parts, you don't set up your feed rates and your speeds in that screen. You set them up here in the nest plate area. You click layer, and it's going to be the color of your part. I only have one layer here, obviously, and this is where you set up your stuff. More on that probably in another video. You'd click load, select the material from a pre-saved list that you would make up at a different point in time. Set up your focus, your air pressure. These are so I remember my gap and my 45-degree lead in, lead out with 0.5 millimeter lead. That's that one I showed you earlier. So these are my settings. No pierce, cut. Just pause the video if you want to look at it. All right. So that is where you would set that up. You'd set it up before you start cutting the first piece. I already had it set up, so that's why I didn't do it. Okay, so now we have clicked on to nest result number 2. We are going to click the start button, and it is going to start cutting the second sheet. And then we will repeat that for all of the sheets that we make. Now, if you forget to do this, you can cut a piece multiple times, as many times as you accidentally keep cutting it. So we've ended up with extra parts a few times. Alright, hope this video was helpful.